All right, how's everybody doing? This is page 104 in book 2, 104. So we're almost getting close to the end of this quarter and the end of this semester. And I hope you guys all doing well. Christmas is just around the corner, so now is the time not to get discouraged. Now is the time to put your 100% effort into all your work, whether it's for algebra or any other class, because you guys want to finish strong. Remember, your semester grade is going to be in your report card, okay? And then you'll have another semester grade at the end of the year after quarter 4. And those two are going to be averaged to give you your all uh, final grade for Algebra 1. So put your best effort no matter what you do. Your best effort, especially now. You want to finish strong, okay, guys? All right, so you're going to have exams upon exams, but if you're prepared, you're not going to have to worry too much. Okay, so we are on page 104. 104. Enough of philosophy. Now let's get into the work. Okay. Now some of this stuff we already went over in some of our periods on what this actually means. So let's just go over it real quickly. It says here solving equations graphically. Graphically. Seeing an equation as two functions set equal to each other, f of x equals g of x. So they try to do it like so basic, step by step. So let's go through it. F of x, you can just call this portion, let's say, f of x. So let's just put 3x plus 4. And then g of x, we can break the other part up into g of x and just assign that x minus 2. See how simple that is? We're just breaking up this equation. Okay. So f of x here would be this first section, 2 minus 3x. G of x would be the second section, negative 4x plus 1. And we just go down the road. See how simple it is? F of x, let's just assign that. 5 over 2x. G of x, the second section after the equal sign. X plus 6. All right. You see, even teachers get tongue twisted sometimes, right? Okay. F of x, 2x minus 7. G of x equals 5. F of x, 1/3 x minus 3. G of x equals 5. Absolute value of x plus 3 equals g of x equals 4. Okay. Okay, it's as simple as that. So we're going back to that original task set before us, solving equations graphically. So what that sounds to me is like you look at two graphs and you can solve it by seeing where they're equal. Well, these are all different values. These are all different values. And what do you think is the one point that both functions share a solution? Well, it's where they intersect. And the intersection is right down here. This value has an x-coordinate and a y-coordinate. X-coordinate is x equals negative 3. Okay. The y-coordinate is, whoops, 1, 2, 3, 4, 5. Y equals negative 5. Okay. You can see that right off. Now, what are they saying us to do? Okay, take a look. In equation, 3x plus 4 equals x minus 2. Just broke it apart into two different functions. We need to see the opposite sides of the equation as two distinct functions, which is exactly what what they did right there. Let's graph them. Okay, here's the graphs. Now, let's go on to the next section. Use the graphs 3x plus 4, which is this, g of x equals x minus 2, which is this, referring to back the previous page. It says right there, to help you answer the following questions. What appears to be coordinates of the point where f of x and g of x intersect? Well, we just did it right here. We just did it right down there. Okay, let's just write it in then. The coordinates are x equals -3, y equals -5. Okay? -3, 5, -5, -3, -5. Okay? Solve the following equation algebraically. Show your work. So we can prove that that's correct by solving the equation. Okay, let's do that. Let's do that. 3x plus 4 equals x minus 2. Okay, we can do it a number of ways. We can just plug the x value, which is -3, in at the beginning or at the end. Okay, why not we do it at the end, okay? Let's solve for x. Okay, let's see what happens. All right, so if I'm solving for x, I want the x to come this side. I'm gonna minus x to both sides, okay? When I do that, that'll be a 2x plus 4 equals -2. I hope that's right. Let's double check. 3x minus x, x minus x. But that goes away. It looks correct so far. Let's get rid of the 4 by subtracting 4 to both sides of the equation. That'll give us 2x equals, what is -2 minus 4? That would be -6, right? And we can see that x would have to equal -3. But check that out. It does verify. It does verify. Now, like I said, we could always do it another way. We could stick the -3 in at the beginning. Let's try that. -3 plus 4 equals -3 minus 2. Now let's just calculate. Did you see what I just did? I took that function. It's like two functions equal each other. Two of them. This one. Okay. And I substituted the value that we think is the correct value, which is -3. We got that from our graphical solution. Now it says here to do it algebraically, okay? And we did it right here. Another way we can do it by substitution. So let's solve that now. What is 3 times -3? That would be -9, right? We bring down that 4. -2 minus -3 minus 2 is -5. And look what we have here. -9 plus 4 is -5. And we come out to -5 equals -5, which is a check. That's a check. Very good. Everything's a check. Look, see? See how wonderful algebra can be? Okay, now let's move on. It says to compare your answers to 3a and 3b to each other. Even this one and this one. What do you notice about the solution to the equation 3x plus 4 equals x minus 2? What do you notice about that? in relation to coordinates of the points, coordinates of the point where f of x and g of x intersect. Well, I do notice that it is equal to -3, which is exactly what we saw graphically. It checks out. And if we all do it another way by substitution into the two functions that equal to each other, we get -5 equals -5, so that checks out as well. Okay? All answers agree. Or you can say solutions. Whether graphically or algebraically. Checks out. Okay. Now, okay, got some graphing. You guys want to get some practice with graphing? Okay, we can do that. So I have this some kind of incredible ruler here that I'm going to use as my straight edge. Wow. Look at that. It's a trippy ruler. Okay. Anyway, for part 4, it says use the space below to take some notes about solving equations graphically. Follow your teacher's instruction. Ah. So this should have been done in class. But anyway, I'm going to show it to you right now just as good. Or even better because you can play it over and over again if you so choose. Okay. I guess we're going to first assign the values of the two functions. I'm going to assign this f of x equals 3x plus 2. G of x equals 2x plus 4. Okay, let's graph them. F of x, y plus 2, okay. What is the y-intercept? What is the y-intercept? It's a 2. So I'm going to mark it right there, 2. That's the y-intercept. Now, one line is going to go through there. The f of x is going to go through that point somehow. Now let's see exactly how it does that. What is the slope? It's 3. Because we're always looking at the y equals mx plus b form. It's the slope-intercept form. So if we have 1 point on the function, we go rise over run, 3 over 1. Go 1, 2, 3 over 1. So mark that point and draw a line through the 2 points that we just created. Using my fancy ruler here. Let's just do that. Okay. Okay. Draw one line here like this. That'll be my f of x. I'll call this f of x. Okay, let's do g of x now. G of x would be, first identify the y-intercept. This is the y-axis, 1, 2, 3, 4. There's a point right there. And this time it goes rise over run, 2 units up, over 1 across, 2 over 1, 2 over 1, and we're going to make a line go through that, okay? A trusty new ruler here. What kind of line is this? Going to look something like this. Keep shifting here. I want to draw it nicely, okay, so we can actually use our graphing. It's kind of steep. Okay. Okay. Something like that. Okay. Second one is g of x. So we'll call this line g of x. Okay, g of x. Now, solve for x, right? We have the variable x. We're going to solve for x. Well, we can do it either graphically or algebraically. But since we're doing lines and graphing, why don't we solve it graphically? So maybe I didn't do that point too well with the line going through it. So it skewed this point. So anyway, to keep things simple, I'm going to call this the intersecting point of the two graphs. And what is the coordinate of that point? Well, I would go 2 across and how many up? 1, 2, 3, 4, 5, 6, 7, 8. So that point is going to be x equals 2, y equals 8. All right, that's the solution. X equals 2. Remember, this is the x. That's the variable as we are talking about the two functions. So when they say solving the equations graphically, guess what? They only want the x value. That's all they want. Given the y value, that's more information than you really need, okay? But in this problem, you're only looking at the x value, okay? You guys want to try another one? You guys want to try 5? Okay, let's try 5. It's good practice anyway, right? Okay, 5. F of x equals 2x plus 3. And you have g of x equals 5. We broke it up into two distinct functions. The f of x, we start at the y-intercept, which is 3. Well, we start at the y-intercept. Keep things simple. Okay, since it's already in that form, y equals mx plus b. What is the slope? 2 over 1. 2 over 1, right there. So from this y-intercept point, 2 up, 1 across, gives us our second point of function f of x. So let's draw that now. Something like this. Okay. And the g of x is simple. G of x equals 5. When you see g of x equals 5, so that tells us that for any value of x, the solution is going to be 5. Any value of x, solution is 5. Any value of x, solution is 5. Okay. Any value of x, y equals 5. Solution, that function is 5. Okay. So here's our x, remember? Here's our x, here's our y, and here's our two functions. It intersects right there. So the x is the variable that we're still looking to solve. And this particular x point is x equals 1. Y would equal 1, 2, 3, 4, 5. But the answer is this right here. Okay? That is what this question is asking. Okay? All right. This video is long enough. Let's end it here. Thank you. So that was pages 104 and 105. Okay? Pages 104 and 105.